Hello, Mr. Thompson here with another video on electricity. This time it's the last part of the unit, static electricity for physics GCSE only, not combined science. So this comes in two parts. The first part is on static charge. Static means stationary and charge means either electrons or protons which have electric charge. So it means stationary charges. You need to be able to describe the production of static electricity and sparking by rubbing surfaces. Describe evidence that charged objects exert forces of attraction or repulsion on one another when they're not in contact. Explain how the transfer of electrons between objects can explain the phenomena of static electricity. So the key ideas, the facts that you need to recall. When certain insulating materials are rubbed against each other, they become electrically charged. Negatively charged electrons are rubbed off one material and onto the other. The material that gains electrons becomes negatively charged because electrons are negative, and the material that loses electrons is left with an equal positive charge. That's due to the protons or the lack of electrons. Also, when two electrically charged objects are brought close together, they exert a force on each other. Two objects that carry the same type of charge repel, and two opposites will attract. Attraction and repulsion between two charged objects are examples of non-contact forces. You'll learn all about forces in one of the next units. So, why do we get electric shocks? The key words here are electrons. Electrons are things that move and they have a charge, and that you get electric field, which is the second part of this video. So what are the three parts of an atom? Just remind yourself, in the middle you have a nucleus, which is made up of protons, which have a charge of +1, and neutrons, which have no charge, and orbiting around the outside is electron with a relative charge of -1. If you have equal number of protons and electrons, that's an uncharged atom, then the overall charge will be 0. The positives and negative cancel each other out. How does a neutral object become charged then? So static electricity is generated through the transfer of electrons between two insulators. When they're rubbed together, one of the insulators gains, one of them loses. So, for example, a polythene rod and a duster. On the left here is before it is rubbed, and you can see equal numbers of charges, positive and negative charges on the duster and the polythene. But on the right is what happens after you rub it. The polythene rub gains electrons from the duster, so the duster becomes overall positive charge and the polythene rod becomes a negative charge. And it's the other way around with a cellulose or acetate rod. With an acetate rod, it tends to lose electrons, and therefore the duster becomes negatively charged and the rod becomes positively charged. So remembering that opposites attract and likes repel. So the magnets in the top and the bottom, if the norths are facing each other, the south will repel. If they were turned around, they would attract. And what about electric fields? The electric fields will repel each other. The two positives will repel each other. A positive and negative will attract. Okay, the second section is on electric fields then. You need to be able to draw the electric field pattern around isolated charged spheres or point charges. Explain the concept of electric field. Fields are common in physics, and we're talking about force fields here. And explain how the concept of electric field helps to explain the non-contact force between charged objects as well as other electrostatic phenomena such as sparking. Again, the non-contact force because they are not making contact. So the key ideas, the things that you need to be able to recall: a charged object creates an electric field around itself. The electric field is strongest closest to the charged object. The further away from the charged object, the weaker the field. And the second charge placed near the field experiences a force. The force gets stronger as the distance between the object decreases. Very much like how gravitational fields work. The closer to the Earth, the stronger the gravity, which is also a non-contact force. Okay, so how do we draw electric fields? Electric field is denoted as arrows from a point, and it looks like this. From a positive, the arrows go away. So the definition of electric field is the direction away from a positive, or the direction a positive charge would move. So for a negative sphere, it would look the same, a radial field, but the arrows would be going towards it. Some things for you to try. I'm sure you've tried this below. Take your balloon, if you've got one, you can blow it up. I'm sure you've tried this before. Rub it against your hair for 20 seconds, or maybe your clothes if you've got no hair. What do you notice about your hair? What might be happening here? What's happening is electrons are being transferred from your hair to the balloon, making your hair positively charged and the balloon negatively charged, so they attract each other. The results in the strand of your hair repelling each other and spreading out. The second experiment, or the one I prefer, is running a light stream of water from the nearest tap, and you bring your balloon close to it. And what you'll see is the running water stream will be attracted towards the balloon. Now remember, the water is not charged. It has neutral charge. But what happens is the balloon will cause an induced charge. So the negative will go on one side of the water and positive on the other, and it will be attracted towards the balloon. And here you go, here's the answer. When you rub the balloon against your hair, electrons are moved from the head of the balloon. This results in a net positive charge on the hair and a net negative charge on the balloon. The negatively charged balloon then induces a charge in the water, resulting in the stream being attracted towards the balloon. And finally, when we get back to school, we'll be looking at the Van de Graaff generator, and this exploits static electricity to create a charge on the top of the metal dome. It results in a highly positive or negatively charged dome. In this situation, it's positive. So you can see the comb maybe at the top of the dome, or in the middle of the dome, that rubs electrons from the dome and takes it down to the earth, and therefore leaves behind a highly positively charged generator, a dome. So explain why your hair stands on end. This is a 4-mark question many years ago. The 4 marks would be: positively charged on the metal dome attracts negative electrons in the person. Electrons travel from the hair, so removes electrons from the hair. The hair then becomes positively charged, and all positively charged things will repel each other, so your hair stands on end. Thanks for watching and listening.